What's up everyone, Patrick here, welcome back. Moving on to the next question. So if the radius of a circle increases by 80%, by what percentage has the area increased? So this is a pretty cool question, and there's different ways to go about it. In general, what's going to happen is we're going to have an initial area with an initial radius, let's call it A1. It's going to have some kind of radius. And then what's going to happen is we're going to increase the radius of the circle by 80%. And with that new radius, we're going to have a new area. We can call it A2. And so what we're going to have to do is we're going to have to find out the percentage change in area, which is going to be what? It's going to be the new area minus the old area all over the old area. And then this we're going to have to multiply by 100. This here is going to give us a decimal, right? So just because the radius is increasing by 80%, it doesn't mean that the area is going to increase by that much. Because if you remember, the area of a circle is what? It's pi r squared. And so because you're squaring that radius there, that's why there's going to be a difference in the percentage change in the area versus the percentage change in the radius. Now, there's different ways to go about this. We can pick a number for the radius. So for example, we can pick, let's say, like 10. And then if we take this radius and increase it by 80%, what's 80% of 10? It's 8. If we add it on to 10, the new radius here, we'll call this R1, R2, would be 18. And then we can plug in these radiuses here for these areas and then use that percentage change formula. Or you can use, for example, an initial radius of 30, and then 80% of 30 is 24. If we add that on, we would end up having 54 over here. It's not going to matter which number you use after you plug in the areas and you put it into here, because this is on a relative basis, you're going to get the same answer every time. But to show this generally, I'm not going to use an actual number. What I'm going to do is I'm going to let the initial radius be r. Okay, so we're going to keep it general as a variable, and I'm actually going to show you why it doesn't matter which numbers you use, because this variable r is going to end up canceling out anyway. So the initial radius, I'm going to let it be r. And so if we take this r and we grow it by 80%, what's the new r going to be? Well, if you remember, the final amount, just in general, is equal to an initial amount times 1 plus the percentage increase or decrease in decimals. Now, I don't want to put r here because we already have a lot of r's. These r's here represent the radius. So over here, you know what, I'll just write it out. So I'll put 1 plus the percentage increase or decrease, because usually we put 1 plus r here for that growth rate. But I'll just put this in words here. And this here has to be in decimals, this percentage. So notice that the initial value is r. Then we'll have 1 plus the percentage increase. The percentage increase is 80%. In decimals, that's 0.8. And so this would end up being 1.8. So this would be 1.8 r. Okay, so that's what the new radius is going to be. It's going to be 1.8 r. There's like a 1 here, and 80% of 1 is 0.8. So if we add 0.8 to 1, we'd end up with 1.8. And this is kind of the work here to show that. Okay, and we didn't have to use r. We could have used x, for example, for the radius. And then this would be 1.8x, or whatever we use here. An 80% increase, we're going to have to multiply by 1.8, whether it's a variable like we're using here or a number. But again, we're going to keep this in variables. So what is this A2 going to be? Well, what we would do is we would take this entire radius here and plug it in here into the formula to get the new area. Now you got to be careful, this whole thing has to go into the brackets for this r. So we would end up with pi 1.8 r squared minus, what's the initial area going to be? Well, the radius is just r, so it's going to be just pi r squared over the initial area, pi r squared, and then we're going to multiply this by 100. Now, what is 1.8 r squared? Notice there's two things multiplying, the 1.8 and the r, so the 1.8 would get squared, and then the r would get squared. 1.8 to the power 2 gives us 3.24, and then we'll have r squared. So this here, you know what, let's continue it over here. We would end up having pi times 3.24 r squared. Let's actually put 3.24 pi. I'm going to take the pi and just put it in the middle there. It's just going to look nicer. So we'll have 3.24 pi r squared minus pi r squared all over pi r squared multiplied by 100. Then notice these are like terms, right? Because of the r squared there, the variables are the same. And there's like a 1 pi here, there's a 3.24 pi there. 3.24 pi minus 1 pi gives us 2.24. Pi r squared over pi r squared. And notice what happens here. The r squares cancel out. And that's why I was saying it doesn't matter what numbers you use, because these variables are canceling out anyway. Right? It's not going to be dependent on whatever that radius there is. And then the pi's cancel out as well. So you'd end up with 2.24, that's in decimals, multiplied by 100. And so you'd end up with 224%. And so that's the final answer. That's the amount the area of a circle is increasing if we increase the radius by 80%.